Moving on, like I said, Scala is a functional programming language, so now it's time to talk about functions, which are obviously very important in Scala. So, go to the resources for this lecture and download the Learning Scala 3.sc file. Hit pause while you take care of that. And just like before, we're going to import that into our project as well. So again, right-click on Learning Scala project, go to Import, go to File System, and select the folder where you download your stuff to, whatever that might be, and select Learning Scala 3.sc. Finish, and you should see it here in your project. Let's double-click that and take a look. Should look like this. All right, so let's talk about functions in Scala. Very important lesson here. Like I said, functional programming. This is kind of the building blocks of it. So syntax for a function in Scala, it looks like this. You start with def, which basically means I'm declaring a function of some sort, followed by the function name, in this case squared. I'm making a function that just squares some value. And the syntax, again, is backwards from what you might expect from other languages. So we start with a parameter of x that is of integer type. The way we say that is x:int. And then the return value of this function is an integer as well. So we have another colon after that function name declaration in the parameters that is followed by the type that is returned by the function. So again, this is totally different from what other languages might do. Usually you would see int squared int x. Instead in Scala, it's squared x int. So just it takes some getting used to, but make sure you understand what's happening there. So again, def means we have a function followed by the function name, our parameters, which have a colon that specifies the type of each parameter, and then finally another colon followed by the type that is returned by the function. And then another thing that's a little bit different is that we have an equal sign between that and the actual brackets for the function, because we're basically taking this expression and assigning it to the square it name, okay? So a little bit different there too. But inside, all we're going to do is say x times x. And again, this is an expression, so remember from the previous lecture that we don't have to actually explicitly return anything. Whatever the last value computed in that expression is what gets returned. So this is all we need for a function that actually squares a value. So let's take a look again. Square it, takes in an integer, returns an integer, and it applies this expression to it, x times x, to actually get the square. Now we can do something similar here for cubing. Again, def cubit takes in an integer x, returns an integer, and uses the expression x times x times x to compute what gets returned. So let's see it in action. If we do println square it 2, you just call the function like you would in any other language. That will return 4. And if you println cube it 2, that will give 8, because 2 cubed is 8 and 2 squared is 4. All right, nothing too crazy yet. This all kind of makes sense, right? Things get a little bit weird now. So remember I said before up here, we're basically assigning this expression to that function named square it. So basically every function in Scala is kind of its own little object, and you can pass these functions around to other functions like they are objects themselves. So that makes a lot more sense with an example here. Let's make a new function called transformInt. And what this function does is it will take a function to transform an integer, it could be any function, and apply that to some integer. So our parameters here in this example are going to be an x, which is an integer that we want to transform, followed by a function that transforms an integer to another integer. So we are taking in here as a parameter a function that expects as input one parameter that is an integer and returns an integer. And that's what this syntax here means. Takes in an integer and it outputs an integer as its result. And the return value of this function itself is an integer set equal to f of x. So we're going to take the function f passed in and pass in the parameter x that was passed in, and what gets evaluated is that function f applied to that value x. So let's see how that works. So for example, we can call transformInt with the value 2 and the function cubit. So this will pass in the value 2 to x and the function cubit to f. The function will then take the function cubit and pass in x to that and return the result. So that gives us back 8, because that will pass in 2 to the cubit function and return 8. And we can print the results, and there it is. Now, for example, we could change that to be square it. Let's just make sure it works. Hit save. Sure enough, we get 4 now, because now I'm passing 2 to the square it function. So, you might want to take a little break here, make sure that sinks in. This is kind of a very fundamental and very important concept of functional programming, that you can pass functions around as parameters themselves, okay? I mean, other languages, this is still possible to do, but you don't see it as often, okay? So very important that you understand how that's working. So stare at these little lines of code here. Make sure you understand what's happening there before you move on, okay? Now, you don't even need to have a separate function declared for this trick to work. You can actually declare these functions in line as well. And if you've worked with me on my other Spark class in Python, this is very similar to how a lambda function in Python works. It also goes by the name of anonymous functions, or function literals is a popular term in Scala. But you're going to see a lot of this, so make sure you understand the syntax of what's going on here. So here I'm calling transform int, and instead of passing in a named function that I already declared, I'm just passing in the expression itself. So I don't even need to have a separate function at all. I can say I'm going to pass in the parameter 3, and I'm going to pass in this expression that takes in a value x and transforms it using the expression x times x times x. And this becomes my entire function definition that I pass into that function. So instead of having a separate qubit function, I can embed what qubit does just right here within this call. So this is perfectly valid syntax in Scala. I can say I have some value x that gets transformed using equal greater than to x times x times x. And that actually works. You can see here that if I pass in the value 3 to transform int, and I pass in this function, x gets transformed to x times x times x, it actually works. It will pass in 3 into x and execute that function on it to get the number 27 as a result. Okay, let's look at it again. So here's another example. I'm using the same transform int that just takes as parameters some integer and some function, and in this case the function, the only requirement is that it transforms an integer to another integer. I'm taking x and transforming it to x divided by 2. So in this example, 10 gets transformed into 5 that way. Okay. One more time, we can do a more complicated expression here. So instead of just a simple one-liner, we can actually do a multi-line expression as well. And in this example, we're going to take the value 2 and pass it into this function that transforms x into this expression that actually does a couple of different steps. It takes a value of y that's equal to x times 2 and then squares that resulting value, and that becomes the end result of that expression. So we take 2, assign y to 2 times 2, which is 4, and then we multiply y times y, 4 times 4, to get 16. And that is indeed what we get back. So make sure you understand what's going on there. You're going to see this syntax a lot in the world of Scala and in the world of Spark in general. So very important you understand that syntax. It's pretty easy to eyeball it, but to get a really intuitive understanding of what's going on, that's important, okay? So let that sink in. And once it has sunk in, I'll give you a little bit of a challenge here. So a very simple exercise here. Every string has a .to uppercase method that you can call on it to just transform the contents of that string to uppercase characters. So play around with some functions. Write a function that actually converts a string to uppercase. And try it out. Actually execute that function on some strings of your own. Make sure it works. And then actually get rid of this separate function entirely and do it in line, just like we did here with function literals. Okay? So I want you to try both doing this with a named separate function that's defined and also with a function literal that you just do in line. So go do that to get some practice with functions. And hey, when you're done, you can say you know functional programming. Congratulations. That's something for the resume. All right, let's move on to our final lecture on our Scala Bootcamp series.